Okay, so this is the automated greenhouse component of the Dura Smart Agro. So from the right side, we have a solenoid valve which is acting as a pump. How is it operating? So whenever the soil moisture detects dryness in the soil, that is whenever there is very high resistance and no humidity in the soil, it starts the pump. So whenever there is humidity in the soil, basing on the configured parameters by the user from the dashboard, the solenoid valve will remain closed due to the fact that there is moisture in the soil. Then we go move on to the temperature control and temperature and humidity control component that is being controlled by the DTH11, this one, and the light bulb. So the DTH11 gathers atmospheric conditions, that is in the sense of temperature and humidity. So whenever the user configures the thresholds for a particular crop, that is the minimum base and the maximum base for the temperature and humidity as a percentage, it triggers switching on of the light bulb or turning on of the light bulb, or switching on of the fan or turning off of the fan. So for example, we are growing tomatoes, and the threshold temperature for this model for this model is 18 to 22 degrees Celsius. So whenever our temperature goes below 22 degree, below that threshold, the 18 to 22, our light bulb turns on, then the fan switches off. Then moving on, this one is an IP camera that monitors the outward appearance of the crop, that is in terms of leaves, stem, and doing AI recognition, image classification of the crop, thus detecting the diseases that are or pests that are affecting the particular crop. So here the Raspberry Pis here are 5-volt Raspberry Pis, but for our supply of the light bulb and solenoid valve, we have 12 volts DC supplies. So here we have a relay that steps up the current, the 5-volt current, 5 volts from the Raspberry Pi to 12 volts. Thus we are able to automate switching on of the light and turning it off, fetching the parameters using the pin data of the temperature control and solenoid valve.